Thank you very much. Good afternoon to all of you. Let me welcome my panelists here. I know we are challenged. We had a break, and we are trying to get people from the break into our session and before lunch. So we will try and do the best we can. Well, thank you all for your attention. This is a panel. As was introduced, I'm Prit Banerjee. I lead our global research and development at Accenture. The panel today, the topic is how to foster innovation in a corporate environment. And so the problem definition is that today most of large multinational companies, right? Many of them represented on the panel here, IBM, HP, Cisco, Microsoft, et cetera, right? Multi-billion-dollar companies, they're constantly being asked, right, to be more innovative, right, by their CEOs. We heard from John Chambers earlier today, right? Be innovative, be innovative. So obviously they are trying to encourage their own R&D organizations, right, in the different divisions, in central R&D and so on, right, to be more innovative, to come up with new products, to be disruptive and so on, right? And obviously a lot of investment going in R&D. I mean, when I was at HP Labs, HP used to invest about 5% of their revenue on R&D, and so does IBM and so on. But what has happened is the appetite for sort of investing in long-term R&D has gradually shifted, right? And so because of quarterly pressures, right, from shareholders and from the board, right? So all companies, large companies, are being sort of asked to come up with products faster and faster. So you can get faster products, obviously, through shorter-term R&D, right? But the really disruptive innovations come from long-term R&D, which is obviously you have to wait, you have to be patient, and there is a very natural tension that happens between the long-term R&D and the short-term R&D. And this is precisely the topic of our panel today. And so when I sort of asked my very, very distinguished panelists to kind of talk about these issues, right, we kind of reminisced about the good old days of Bell Labs and IBM Research, right, where essentially those researchers in IBM Research and Bell Labs could just go in a closet and think about inventing the transistor, inventing the laser, inventing disk drives, and so on. At those times, right, there was essentially a cash cow from AT&T, right? Essentially 2% of all revenue from AT&T goes to funding Bell Labs. So Bell Labs was not quite as responsible, right? They didn't have to deliver innovations every week, every month, right? Fast forward to 2015, right? Most of these big companies, right? I mean, all of them have central R&D, as we will see today, right? And they're being challenged about this area. So this is what we are going to talk about today. How does a large company, right, all the companies represented here today, right, balance this trade-off between long-term R&D, short-term R&D, right? There's a lot of disruptive innovations happening from the startups out there, right? The Airbnbs and the Ubers and the Instagrams and so on. And many times, right, these large companies just acquire these startups, right? And that's a way to bring innovation faster into a company, and that we call inorganic innovation, by acquiring the innovation, right? So we are going to address these issues in our panel, the organic versus inorganic, right? And the panelists will address this issue. So we have a very, very distinguished panel. On the left, we have John Apostopoulos, who is Vice President and Chief Technology Officer of Cisco, Cisco's enterprise business. He has a PhD from MIT. He has received many, many awards. He's a recipient of MIT Technology Review, and he's got hundreds of papers, fellow of IEEE and so on. He used to be my colleague at HP Labs when I was at HP Labs, so an absolutely brilliant man. We'll talk about innovation as it happens at Cisco. Next to John is Peter Lee, who is just absolutely another amazing person. We're delighted to have you on the panel. He is Corporate Vice President and Head of Microsoft Research, the Next Generation Experiences. Peter has a really exciting background. He has a PhD from Michigan. He used to be a professor at Carnegie Mellon. He was the head of computer science at Carnegie Mellon, as you know, one of the best computer science programs in the world. And then he was a program director at DARPA, and now he is leading corporate sort of research at in a large company. So he's essentially, I was just chatting with him offline, right? He has kind of done research in a university setting. He has funded research from government. He's also worked in a corporate setting. So he'll be able to share a lot of personal experiences here. Next to him is Rajesh Pankaj, who is Senior Vice President of Engineering at Qualcomm Research. Again, amazing background, undergraduate from a competitor IIT, IIT Kanpur, competitor from mine, PhD from MIT, also was in academia. He was a professor at University of Toronto, and now leads lots of fantastic work on, again, Qualcomm is very well known for CDM and so on. He was one of the pioneering engineers at Qualcomm in that area. Next to him is Chandrakant Patel, again, one of my wonderful colleagues in my former company, HP Labs. He is the chief scientist and HP senior fellow, very, very distinguished career at HP. He is an undergrad from UC Berkeley, master's from San Jose State, extremely well known at HP and in the Valley for his significant contributions in the area of networking, storage, computer architectures, data centers. His passion is about sustainable data centers. He'll talk about innovation and so on. His claim to fame, he's been recognized last year as he's been inducted to the Silicon Valley Hall of Fame. Amazing individual. We are thrilled to have Chandrakant here on stage. And finally, we have Jeff Welser. He heads up IBM Research, Almaden Research. Wonderful organization. As many of us know, IBM Researchers, Almaden has done phenomenal research in relational database, disk drives, and some cool innovations have just come out from IBM. I'll let Jeff talk about it. He has got a PhD from Stanford, member of the IBM Academy of Technology. Really, really distinguished panelists, as you can see, right? So I'm going to go around and ask each of them to talk about the R&D organization. So we're going to start with you, John. Why don't you talk about the innovation labs you're running at Cisco and address some of the issues?
Sure, be happy to. So as Prith mentioned, there is this really big tension that has been around for many, many years in regard to investing for the future versus investing for near term, this quarter, this year. Let me tell you a little bit what happens at Cisco and how our diverse portfolio for trying to tackle this problem. Cisco, as you probably heard this morning from John Chambers, is about a 75,000 person company, of which about 25,000 people are engineers working to build our next generation products. Of this, so we spend about $6 billion organically on R&D. There's also a huge amount of investment in terms of acquisitions in new technology areas. And every year there's from $1 to $4 to $5 or $6 billion in acquisitions. So there's a huge amount of internal investment in R&D, a huge amount of acquisitions also in this space. As you can guess, there's a lot of work with startups, particularly in terms of trying to guide startups in terms of what are the right directions. Same thing with universities, same thing with standard bodies. A couple of things which are, and this is probably true for all of our different organizations here, a couple areas that are maybe a little bit more unique to Cisco, which I'll share, is that, first of all, sometimes some of the projects you work on that are highly ambitious don't align with any of the research projects or business groups in your big company, even with 25,000 engineers. And the question is how to go after those internally. So what we do is we have something called an innovation fund, where anybody in Cisco can propose to work on a particular ambitious area. And if we believe this is the right thing for Cisco to invest in, we can provide additional funding for this small group of people to work in this area. This is usually on the order of $500,000 to $1 million per year. So it's really an exploratory effort. And if this pans out, then we scale it up. We call this an innovation fund. And John Chambers was the person who set this up. Another thing we're doing is something called escape velocity architecture. And this relates to the problem that a lot of the problems our customers have are really big challenges where one or two different components put together don't solve it. So you need to look holistically to figure out how you can solve this. So what we try to do with escape velocity architecture is figure out, for our customers' main problems, what is the North Star architecture we have to design to solve that? This may be 3 to 5 to 7 years out. Now, based on this North Star architecture, where are we today, and what do we need to do to get from where we are today to this North Star architecture? This may mean that we build things internally. This may mean that we work with our colleagues and other companies to build it, or our partners and universities. But what do we need to do to get to this North Star architecture? So that's something I'm heavily involved with And it's very, very challenging, but it can have a huge effect on the company. And a key aspect of this is you look holistically across what is the solution that needs to be built from an end-to-end point of view and try to put all these pieces together, from internal, from working with collaborators and so forth. So these are some of the things we do at Cisco to try to tackle this tension and to invest both for the current and for the future.
Thank you, John. So Peter, why don't you talk about some of the innovation that, I guess, the organization, Microsoft Research, and how innovation happens at and is supported at Microsoft?
Sure, and it's really such an honor to be here in front of this audience and with some of these distinguished colleagues. I think we got a lot of work done just backstage talking to each other, which is great. So Microsoft Research is a very proud and old organization in tech terms, not, of course, as old as IBM Research, but we've been around for 24 years. And traditionally, it was set up as the kind of open, blue sky research organization, indexed to be about 1% of the total headcount of Microsoft. And that's been maintained now for a very long time. So that means we're about 1,250 people scattered around 12 labs around the world. And roughly speaking, the organizational structure is in two halves. There's one half, which is very familiar to almost any academic researcher. It's organized into laboratories. Each laboratory is organized into groups, and those groups are very devoted to advancing human knowledge and the state of the art in the grand areas of research in computing and related fields. So for example, we have computer vision research groups, machine learning, cryptography, and so on. The other half is much more mission-oriented, and there the organizational structure is much more around teams that are incubating, oftentimes end-to-end development of new concepts, either business or technical concepts. So a great example of that is the Skype speech-to-speech universal translator. And in those situations, you have a little bit less stability. Teams are incubated, stood up, torn down in a much more kind of rapid basis. But it allows us to kind of draw from the kind of more open lab into areas that can really drive innovation much more quickly. Now, the thing I wanted to say before handing the floor back is Microsoft has been undergoing gigantic, tumultuous changes over the past year, driven largely by our new CEO, Satya Nadella. And those changes have really just put a huge focus on Microsoft Research. And that has been an exhilarating experience. And I mean exhilarating both in the sense of absolute excitement as well as absolute terror in what we've been doing. The way that I've explained it to our people is to tell a story from my childhood. When I was about 7 years old, I grew up in a small town in Upper Michigan, and my parents, on a summer vacation, took me to my first theme park, and I saw for the first time a roller coaster. And so I was desperate to ride it. Unfortunately, I wasn't tall enough to go. So it actually took another year or two before I had a second chance. And when I finally was able to ride it, I got strapped in. And as I was going up that first hill, I realized this is a horrible mistake. And of course, there's no way to get out. And by the time I finished that first ride, I wanted to ride it again. And that sense of exhilaration, I think, is at play probably for all of our organizations, where right now the tech industry is so desperate for innovation, so desperate for the next big thing. And for better or for worse, all the smart tech CEOs are looking at their innovation departments, which roughly speaking are represented here, and expecting us to deliver that. And when you look into our researchers and engineers' hearts, 2 years ago, this is what every single one of them believed that we could do, and that if only we were given the chance. And now that we're being given the chance, there's a kind of exhilaration. And so that is just bringing, I think, a lot of new thinking and, importantly, new culture. I was very impressed with John Chambers' keynote, where he emphasized culture. And I think that culture is something that we're really focusing a lot on now in Microsoft Research.
Thank you, Peter. So moving on to Qualcomm and Rajesh, I would like you to talk about sort of, I guess, the tie-in with the business model of Qualcomm and the R&D. I would like you to focus on this. We're talking backstage. So.
Yeah, it's very interesting. So those of you who don't know Qualcomm, one of our chips is most likely in your cell phone. And we have been the pioneer on the communication side for years. We originally were the first company to commercialize CDMA, and we had to go through this massive battle with the rest of the industry, but it was technically a better solution, and that's how it won out. And what happened in the early days when we invented CDMA, and we said, well, how do we commercialize? And we realized that we needed partners. We couldn't do everything ourselves. We couldn't make phones and base stations and everything that goes with it and standardize everything. So our founders, right from the beginning, had this notion that we needed to license our technology. And that sort of got going into this whole licensing business model that we have, we have a pretty good licensing business. It's a fairly significant portion of our revenue and profit. And the revenue that comes in through this licensing model actually is the one that allows us to then go to the next generation of research, and we've been able to feed that back into the whole industry. So basically, all of the communication companies, the wireless communication companies that you can think of, are basically our licensees. And that had been a really good, positive feedback loop for us. It's kind of rare to see that happen, but I think the reason it got started is when we first talked about CDMA, nobody believed in it, and so we were the only ones who were trying to sort of make everything happen. By the time people realized that they needed it, they didn't have time to develop it themselves. They had to come to us, and that sort of allowed us to sort of stay ahead. And that has sort of continues until now. And in some sense, I find myself a little bit lucky because I'm heading the Qualcomm research engineering department over there. My boss, the CTO of Qualcomm, is Matt Grob, and he oversees that, and he oversees a few other things also. But we have the charter to basically come up with a new technology. And in communications, I think, wireless communications particularly, I think we have been able to continue to innovate. So it started with CDMA. When I joined Qualcomm about 18 years ago, we were working on the first high-speed data. And back then, 1 megabit per second was considered high speed. That was the late 90s, because most you can get on wireless was a few hundred kilobits per second. So we did that. Again, at that time, nobody believed that you would actually need megabits per second for your cell phone. Now, of course, nobody questions that. A few years later, then LTE transition took place. And again, we were able to take our R&D and put that in there and make sure that we have the technology, the right technology that we can give to the world. And we have continued with that model, which has been very fortunate for us. In the last few years, as smartphones have exploded in terms of capability, of course, our R&D had to keep up with that. So we have gone beyond communications now, and pretty much any aspect of mobile computing, we have R&D projects in there. And the R&D projects that we have typically span between medium term and long term. We don't do short term R&D because that is generally done by the product group. So if you look at all the R&D expenditure for Qualcomm, it's actually a much bigger number, $4 or $5 billion, depending upon how you count and which quarter you're looking at. And we in Qualcomm Research is a much smaller, we are a much smaller entity, less than 1,000 people, but still it's a fairly significant number. So that includes medium-term and long-term R&D. And one other interesting thing that we have is that Qualcomm Ventures, which is the VC arm of Qualcomm, also reports to my boss. Okay, so we have pretty good relationship with the VC arm of our company, and what that means is what's going on in the startup world, we generally are quite familiar with that. We have pretty good insight into that. Now, because of our licensing revenue and importance of that for Qualcomm, it isn't usually possible for us to have very good close collaboration with other companies, but we try to figure out ways to sort of work with them, and then sometimes there are acquisitions, and we can talk more about that later on. So that's the kind of model that we have at Qualcomm, and it really has been quite good. And working there for 18 years, it has been quite interesting for the same sort of reasons that Peter was talking about. We are asked to come up with the next technology. When we know that the rest of the other companies and the rest of the world is, has a target on our back because they want to get at us, and we need to stay ahead. And we have been doing pretty well in that, and that's a pretty good feeling.
Thank you, Rajesh. So next we want to hear from my good friend, Chandrakant. He was my great colleague at HP Labs. He's sort of Mr. Innovation at HP, and in his role as sort of senior fellow and chief scientist. Why don't you talk to us about sort of HP's approach to innovation in HP Labs and how some of the, again, the challenges that we both faced together and today. Why don't you talk about the current organization?
So first, thank you very much. It's a delight to be here. And Prith, I'll pick up where you left off. So when Prith left, I ran HP Labs reporting to Meg, and subsequently, Meg asked me, what do I want to do? And I, in light of the challenges as articulated by Peter, I felt that we needed a new innovation framework. First, I recognized that the innovations we will be doing in the future are cyber and physical. So we've been living in the cyber world, but tomorrow, the kinds of things we'll be doing will be physical and cyber. And so these cyber-physical innovation, just like articulated by John, manifest themselves as systemic innovations or solutions, and therefore they require a multidisciplinary, they beget a multidisciplinary approach. So with that in mind, the way we have organized labs is as follows. There still has to be 20% of work, or maybe 20 to 30%, that has to be Bell Labs equivalent. After all, if Bell Labs didn't exist, or if IBM and HP didn't do the research that they did early, we wouldn't be here. And I might say that we are living off the past, and we are quickly running out of things. So there has to be that. But given that we just can't do that and survive, there has to be these systemic innovations that have to be quickly developed. But we cannot continue to hire in silos. So what I articulated to Meg was, and I have to tell you a story just like you. I grew up in a small town in Bihar, India. And since I was not distracted by the frivolous things we do on the internet today, I was a very good sketcher. I imagined things and I sketched. And I used my sketching capabilities and connected with Meg because she likes maritime analogies. So I said that, Meg, you are on the bridge. I'm the chief engineer in the engine room. And ours is a multidisciplinary engine room. And today's innovations are systemic and multidisciplinary. So we have to figure out a way to horizontally go across the organization and build those systemic innovations. Many of these companies have those multidisciplinary skills. A lot of the startups don't. So one of the things we have built is we look at the trends, we come up with ideas of systemic innovation, and draw upon these pools of horizontal pools of disciplines I've created. These are experts in silicon, reliability, printed circuit board design, firmware, programming languages, and draw them from across the company, from Bangalore, from Puerto Rico, from Brazil, to quickly bring them together to solve a problem and go back. So this is an approach we are taking to go beyond the hierarchical organization we have today, and in the engine room, get the amplification of ideas from that 80% portfolio to quickly act and develop those systemic innovations with the people we have within. That is our ecosystem of talent. And then, like was articulated by yourself, we also realize that in doing the systemic innovations, there are certain gaps. Can we find those externally? Universities are a great example to leverage. Startups are very good examples. So you could think of affinity groups in light of what you're trying to do externally, and affinity groups in your own engine room. So if you're interested, I'll send you the sketch I sent to Meg, and that sketch guides us today. And everything is built on that ideas to value framework that has those key salient elements: the engine room, the bridge, the trends that precipitate those ideas. And give us a few years, and we'll be back.
Thank you, Chandrakant. Finally, our last panelist, Jeff, I would like to hear about your sort of, again, IBM Research is a very, very revered organization. Talk about your current organization, IBM Almaden, and all the latest innovations that are happening from IBM.
Sure, I'm happy to do it. I have to say it's nice going last because I've heard little bits from each of you. I already thought some things I want to do slightly differently now based on what I just heard. I'm actually hearing that certain things that we are doing, you can hear resonance across it. So IBM Research will be 60 years old next year. And when we started, we really were an academic model in the purest sense, like AT&T Bell Labs. In fact, we started in a frat house at Columbia University, with Columbia at the time. And that's clearly evolved. So if you look at us today, we've got about 3,000 researchers globally. And this is the research division itself. And up until January of 2014, we were organized around disciplines, like you would see in universities. So we would have the math group, the applied math group, the software group, and et cetera. And we realized that this transition, this sort of horizontalization that we heard them talk about at Cisco was going on. And we said, well, if we're serious about going that way, we need to actually do this even with the research teams. So we actually reorganized the entire division around 4 strategic areas. One is science and technology. And if you look at that, to be honest, it did not shift much in its departments, because there's a reason you have the physicists and the chemists working together in their discipline, because they really are building blocks that will then, of course, everything else will be built on top of. But everybody else got mixed around. So we have a computing as a service group, which is hardware and software researchers. So the software researchers that really write the software right on that bare metal, right on top of it, right? Nothing above that. Hardware from pretty much the circuit designers for the chips up. And our service science engineers or researchers who think about how you run large data centers and interact with other companies. And their whole mission is continue to deliver on the IT roadmaps, but now you're delivering computation. And that may or may not involve selling anybody hardware or software. It may be a service, it may involve hardware and software, it may be some hybrid. But you should be thinking about that from the beginning so you aren't over-optimizing the researcher on the hardware or software piece. You should be doing it together. Next to that, we put the cognitive computing pillar, which is, again, hardware and software researchers together thinking about if we move away from von Neumann, if we move away from the kinds of computations, just speeds and feeds we've done in the past for computation, to things that look more cognitive, finding big data analytics patterns. What does that mean from a software and hardware point of view? So obviously, the Watson machine playing Jeopardy was all software. It was all on a very standard system. Algorithms showing that you really could do amazing things, even just in the software side. But there's a whole world of things that you do on the hardware side. We did a chip on the neural nets recently that was about the way the brain's actually structured to try and get the power levels down, for example. So that whole group looks at that. And the last one is industry and solutions. And these are still the research guys. It's a lot of our applied math guys. It's a lot of our software analytics guys. But with there, we also have domain expertise. So we hire in PhD equivalents in healthcare. We've got medical doctors on staff. We've got people in telecom or finance who are researchers themselves in their own fields. In fact, one of the things we want is them to continue to publish and advance their field, because otherwise we can just hire a consultant. I mean, if we just need the domain expertise, you can always do it that way. So doing that research together to think about how you build actual solutions in those domains. So I think that whole reorganization has changed the way we think about it, so that we are feeling like we are always building from the beginning what we want to go after. Now that being said, we want to stay a research division. So to your point on the funding, about half our funding still comes from corporate with sort of no strings attached. It's your base funding for research. The other half comes from, part of it from our business units. So we always have joint programs with all of our business units, and all of our groups know that they have to do something to make sure their pipeline is being filled for the business unit. And some comes from DARPA, NSF, client engagements, lots of joint development. We do a lot of work actually with other companies, in our case, to do that development work. So that kind of makes sure that we are keeping a foot in the other side, right? How are you going to get this out the door? And we actually have this all in one group. So almost every group has a portion of their funding coming from different areas. Obviously, the groups working on further out stuff tends to be mostly base funded. The groups doing more near-term stuff tends to be more aligned with the business units. But I think that mix actually has been very important. And the last thing I'd comment on is that we continue to push on research where we think it's going to be important to us, even if we ourselves are not going to go and manufacture it. So I think people probably heard about the 7 nanometer announcement, the 7 nanometer chip announcement that we did about 2 weeks ago. And that was just after we had, of course, announced that we'd finally closed the deal with Global Foundries to have them take over our chip manufacturing. And we wanted to underline the fact that we gave them the chip manufacturing. We kept all of the R&D internal. So all my science technology guys, my researcher guys are there because we think it's going to be incredibly critical to us to make sure that roadmap continues on process. We just want them to make it for us now, right? So that's sort of the model we're after.
Thank you. That was awesome. So I wanted to, already questions have started popping up from the audience. Thank you very much. I will get to them, but I had a couple of questions of the panelists before I take the audience questions. One is on the role of sort of, as companies, these large multinational companies on a journey to try and sort of get the maximum output of organic innovation, things that you organically create, right? With the inorganic, what I have noticed in my years in academia, startups, and the corporate world is that it is easier for these large companies to do the organic innovation in their own areas of strength, right? So if you are in Google, right, the best innovations on search technologies will continue to come from Google. Yet, even the most innovative company like Google has to go and acquire Android or acquire Nest or acquire YouTube because that's a non-adjacent kind of a thing, right? So the question I wanted to ask is, culturally speaking, how have you changed the culture of our R&D to say, you know, my role is to not necessarily do the invented here, right? But my role is to bring innovation to the company, to my customers, either from within or by identifying innovation from outside, right? And if it is from a startup, a role I can play is to partner with the startup, as Rajesh was saying, and just tell our company, we should partner with the startup. Let's acquire the startup. And once the startup is part of us, then we can together build interesting solutions on top of it. So that's the concept of open innovation that has been, again, pioneered by Henry Chesborough from Berkeley and so on, talking to universities and so on. So I want to kind of ask each of you, well, I'll start with a few. Start with Peter, because I know you have worked in DARPA and universities and so on. What do you think of the role of open innovation in the bigger context, universities, startup companies, and bring those innovations to Microsoft?
Yeah, this is an area that has just become so much bigger and so much more active in just even over the last few months, over the last few years. You know, the kind of agility and drive and creativity, especially in value creation and in development of business models, is just so impressive and so vibrant. At the same time, I view our role next to the startups as somewhat complementary, because there's also a technical depth. You know, whenever we engage with different startup communities or VCs, you know, we see huge technical gaps where startups are desperately trying to employ data analytics or machine learning or natural language processing. And roughly speaking, it is at, not to disparage it too much, but roughly speaking at a Stanford grad student level. And so you can see a potential for kind of complementary strengths to be brought together. And I'll bet we all have our examples of this. And so a big focus for us in MSR is to go beyond just playing the role of the technical due diligence arm for acquisitions in Microsoft, and actually try to find ways to partner and inject uniquely deep technologies that we have in partnership with startups, particularly startups that might add value to our ecosystem or might create surprises for our competitors' ecosystems. And I think we've been particularly focused on that in the China market right now, since there's some ability for us to limit some risks and also really try to capture the large wave of venture capital activity going on there.
Great. So there's a question from the audience. Again, thank you for using the app. I've been monitoring the app on my phone here. The question from the audience is about, we talk about disruption in technologies and so on, but is there disruption happening in the corporate R&D organization itself? I think, Jeff, you kind of highlighted, you kind of mentioned that, but could you go a little more into how has the corporate R&D, IBM Research, disrupted itself as an organization?
Yeah, so I already mentioned sort of the organizational changes we've made, but if you look at it, I would say two things. First of all, it's a journey, and we aren't actually complete in any of this. So in fact, to the culture point, if you look at those 4 pillars I talked about, of all those, the computing as a service is the one that's been the biggest challenge culturally, because although it looks great on PowerPoint, the org chart's all been remade, getting the people to actually work together and talk together and think differently about their research in that where they're continuing a mission that is not that dissimilar to what they were doing before is extremely challenging from a cultural standpoint. On the other hand, if you look at the cognitive computing or the industry and solutions pillars, they just jumped in because they have a whole new mission already, and they were more than happy to try and figure out how they could work together to they knew they couldn't do it by themselves, right? They knew no one knows how to build a brain. We don't know how to do these things, right? So how are we going to do this together? So I think that's actually been really interesting. The second thing I was going to make a comment on is I think that we keep challenging ourselves even to make sure that there's a reason we're a research division, right? So obviously we make sure that we're publishing papers and leading conferences and interacting with universities, but how do we make sure we're really challenging ourselves beyond just what the pipeline needs. And we do this through these grand challenge processes, and we do this both at the local lab level as well as sort of the global research level. And so one of the challenges, of course, that everyone knew about was when we played Jeopardy. And that started off as a grand challenge. Somebody came up. There's this process we use for just crowdsourcing ideas. We kind of let it be very grassroots, and someone votes on saying, hey, let's just do this. So we made an effort about 3 years ahead to say, let's see if we can beat Jeopardy, beat the people in Jeopardy. We're also doing something that's completely tangential. Like right now, we're working on something we call the Battery 500 project at Almaden, which is, can you make a battery that'll go 500 miles on one charge? And we're never going to make batteries, I guarantee it. But it may totally change the way the transportation system works, the way the smart grid works, and all those things we care a lot about for our clients and what happens. And it also happens to advance and take advantage of and advance our own materials capabilities in areas that we wouldn't necessarily do otherwise. So I think that's how we continue to try to push ourselves to make sure we're disrupting ourselves both on the science side while we also figure out if we got the solutions that we need.
Great.
Actually, two quick comments there. Because I thought it was just really on target with a lot of the changes. One is, I think there's been a huge movement towards having very easily accessible goals for research efforts. Those research efforts can be very long-term, but there still has to be a clear answer to the question, have you accomplished your goal or not? And that's in contrast to the old model, which was really much more open-ended and exploratory. The other is, our colleagues, our researchers' colleagues now are just as likely to be at companies as they are at universities. And I think one reason is product engineering teams, like if I think of Qualcomm, product engineering teams actually are thinking pretty long term. Because sure, they have this year's thing to ship, but that's on a roadmap that goes out to V3 or V4, which could be 3 to 5 years out. And that is extremely challenging for our researchers to look beyond those headlights. And in a way, I find that oftentimes we're having to think much further ahead than, say, the annual conference deadline that's traditional in academia.
Yeah, actually,
there are so many questions. I want the panelists to kind of address this. There's a great question on how do you encourage business innovation? We have been talking about technology disruptions and technology innovations. How do you encourage and support business innovation in a corporate setting? I don't know who would like to take that.
I can talk a little bit about that. So one of the most interesting challenges that we have faced has to do with wireless over unlicensed spectrum versus licensed spectrum, okay? And they sort of have been two completely separate businesses for a very long period of time. And as time has gone on, you can sort of see that on the people who work on licensed spectrum, they are trying to get into the unlicensed spectrum domain by talking about small cells, something that is more like Wi-Fi. And people who have been thinking about unlicensed spectrum try to get into licensed because they want to use Wi-Fi to, for example, cover a larger area, which is traditionally has been more of a licensed spectrum play. And so we started thinking about that, and we said, well, really, if it's all in a continuum, how about we say, we take the best of both of these things and put it together and see if we can come up with the best technology. So I wouldn't say this is just a business innovation, but it's a business innovation that's driven by the technology insight that we have on the two different sides. And something that we announced very recently, something called Multifier, which is taking LTE technology and some of the great aspects of that and putting it in unlicensed spectrum. And we got a little bit of controversy for that, but there's good reason to do something like that, both from technical and business point of view.
There are lots and lots of questions, but the last one is really, really interesting. How do you justify your high compensation to your bosses? I love the question.
That's an assumption.
That question. First of all, we are not highly compensated. I think the question is asking about ROI. So let me ask you, John, how do you measure ROI in innovation and at Cisco?
Wow, so the ROI question has
Or
been
your you want to go for your compensation? Go for it.
Yeah. The ROI question in research and advanced development is one of the biggest problems that all of us face here. Because what happens is that Wall Street looks at this quarter's numbers, this year's numbers, and they're not really thinking about long term. So this is something that internally, us, the management staff, the business culture, the culture itself has to realize this is important and has to realize we have to invest some amount of our work in some of our budget, resources, and so forth for the future, and also understand that some of our most talented people are going to go after ambitious things, and they're sometimes going to fail. And we want them to actually fail. We want them to fail quickly, so that they can go on to the next thing. So these are some of the things we try to do to succeed and to also convince the people who are focused on ROI that, hey, this will help our companies be around 5 years from now, 10 years from now, and so forth. There have been these studies that have shown what fraction of the companies, I forget who the authors were, but some of the estimates are that in 10 to 25 years from now, 80% of the high-tech companies that exist today will no longer exist, right? Maybe one of my colleagues may remember that stat better. But a lot of these companies today are going to disappear because they're not investing for the future, because they're only focused on ROI for the current quarter as opposed to for the next 5 years and so.
That's a great thing. We are unfortunately out of time. I wanted to thank you, all the panelists, for a great panel. In other conferences, you would have each of these panelists give sort of plenary keynote sessions. Please feel free to talk to them. They'll be available during lunchtime. I think it is lunchtime now, and the session begins here at, I think, 2:10. So thank you to the entire audience, and thanks to the panelists.